Hi everyone, this is Team Diversity. My name is Shihan Wu.
My name is Chidibem Enyekwe.
My name is Levi Winkles.
The title of our project is Fast Regular Expression Matching using NFA. Regular expression is a notation for describing set of character strings when a particular string is in the set described by a regular expression. We often say that regular expression matching the string. Every regular expression has an equivalent NFA. We can convert the regular expression to an NFA. The NFA can then be used to test whether a regular expression matching the string.
So now we're going to kind of delve into regex, converting regex into an NFA. So asterisk matches 0 more occurrences, question mark matches 0 1 occurrence, plus matches 1 or more occurrences, line matches A or B, and parentheses groups up characters. So a single character, it's just an initial state, and with a transition, so it just produces an A. Concatenation of A and B. So A is E sub 1 and B is E sub 2. They concatenate, and it produces E1, E sub 1, E sub 2. With an OR, you can go one of two routes. You can go E sub 1 or E sub 2, either or. This is a one or more occurrence. E is 0 or 1, you can go with E one time, or you can go the bottom arrow and terminate the program by not selecting anything. 0 more E, you can keep looping and get numerous E's, and then after the last loop you can go through the bottom and terminate the program. 1 or more E's, you can exit with just 1 E, or you can keep looping and build up a string of E's and then exit the program.
Alright, so now let's actually run this program and take a look. But before we do so, let me show some sample file that we'll be working with. So we have our first test file, we have our regular expression string, the meaning of the regular expression, and a couple of strings for it to match. The same thing applies for this file and this file. So here is our program running already. So we have that first file that I showed, our string ABC, so it match if the string is ABC, and if you notice, the only two that are ABCs is the first two. Secondly, we have the other file that says match starts with a number, then ends with a vowel, like you can see in the message right here. And you see the only two that matches is these two. Some of us might be worried, oh, wait a minute, why isn't it matching the last one? The reason it's not matching the last one is because we have a % sign right there. Finally, we have our third file. This was more of a fun thing. So what we're doing here is that we're matching any string that starts with turn down for blah blah blah. So a couple of examples we have is turn down for what, turn down for who, turn down for when, turn down for Dr. Min, turn down for Jivas, turn down for Dubem, turn down for Levi, and turn down for Chihan. Now let's actually dive into some code, because what's life without code, right? So let's see right here. So the two main things that I would like to point out is actually three key features of this program, right? What we are looking at. The first one is regex to postfix. You remember in our execution, we had the postfix notation. So that regex to postfix turns this regular expression into this right here. And the postfix notation is what we use to build our NFA engine, our NFA tree. Next up is regex postfix to NFA. This method right here gets a postfix regex string and transforms it into an NFA tree. Next up would be the match function. And what does the match function do? It just passes through the NFA tree. So we get our string, we iterate through our string, and we have a step method to help us step through things step by step. Now, we're going to close things up by talking about improvements that we did. Improvement-wise, the main thing that we were able to get functioning is wildcard support. Wildcard support enabled us to be able to go ahead and say something like dot. Right here, dot means use A to Z and 0 to 1. The other thing that we were working on but we couldn't get to function properly was print NFA and support for character classes. Support for character classes would help us eliminate mundane tasks like so right here, where we have to specify 1, 2, 3 all the way to 0, where with a character class we can simply say /d to represent all the digits or /w to represent all alphabets and digits. And this is the end of our presentation. I hope you enjoyed it. We had fun working on this, and if you have any questions, feel free to ask. Thank you.